Hello, we're Team 6 and we're going to present our current projects for the problem situation. My name is Andres Morales.
My name is Emiliano Gonzalez.
And my name is Mauricio Gonzalez.
I will start by explaining how the manual and the automatic movement works. The way this works is that by the manual movement, we have a normal button, that type where you press it and then it goes back up. This way, once you press it, the circuit will change it, will take it as a true and then move a certain amount the curtain so that you can control specifically where it will go. And the way the automatic movement works is that we have an interlocked push button, which means that once you press it, it's going to stay pressed unless you press it again and then it goes back up. This way, in the loop, we have that while the button is being pushed, we are going to move a certain amount. And once the button is stopped being pushed, it will stop moving. That's about it. And for the indicators that we have the number of cycles, have the number of people that have gone through or the accidents, and we have the indicators for when the curtain is at its maximum and minimum height. The way this works is that for the number of cycles, we have an if, where it is basically saying that if the past state is false and the new state is true, it will count it as one into the cycle of the current. For the cycle of the number of persons or the number of incidents that have happened, it's basically if you push the button that we have in LabVIEW, which simulates the detection of the sensor, it will go one to the cycle. It will add one to the cycle. And the way the indicators for the minimum and maximum height work is that if the curtain is detected to be at its maximum or minimum height, an LED or a light will turn on.
Now we're going to the part of the person detection and alarm. We can see it right here in this button right here in this case structure. Basically, when the person sensor detects movement, the system triggers two things simultaneously. The curtain rises automatically to its maximum height and an alarm activates. At the same time, the incident counter increments by one. This gives the supervisor a running log of how many detection events have occurred. You can see the alarm indicator right here in the HMI and the number of incidents display updates in real time, which can only be cleared by the supervisor. Now, with the velocity control, the speed of the curtain is governed by a simple physical relationship. Velocity equals distance over time. In LabVIEW, we implement this by using a delay control over the HMI, which we can see over here in velocity control. The supervisor can set a delay value in milliseconds, and that delay is inserted between each step of the curtain movement. A longer delay would mean a slower movement, and a shorter delay would mean a faster movement. The supervisor is the only person in charge who can control this variable. Finally, we have the maximum height control, which is also a supervisor-only control on the HMI. When the supervisor sets a value, it creates a local variable that carries the value over here into the logic of the automatic and manual movement modes, which is automatic rise and manual rise. Each of those case structures read the local variable over here. We can see that, and it uses as the upper boundary. So when the curtain is raising it, it compares the current height display against the maximum value and stop exactly when it reaches it. This means the supervisor can dynamically redefine the travel limit without touching the code by only clicking here in the HMI interface.
Finally, we have to set the value of the counters, first of the cycles, and the indicator of accidents. This is done by using some Boolean logic where it just compares the first case to the second one, and after that, they doesn't proceed to the case. And finally, there is a button of the clear incidents that is a supervisor-only feature that just multiplies the value of the number of incidents by zero to reduce it in case as a reset is needed. Then it is the emergency stop, which is a key feature in this curtain because to avoid any accidents, all movement and register needs to be stopped. This is done by a whole case structure that englobes while false all the movements and counters, and while true, it stops everything. Finally, there is the user and login password, which is done by comparing two strings, one with the a username, which will be admin or operator, and one with a password. That in this case, we wanted to keep it simple, for example, which is a set of four numbers. In this case, it compares both values, and then with an AND logic, we pass it to a case structure. When this becomes true, it enables some functions or disables them to show the functions that each role has. Then for the test of our simulation, we will run a brief test of all the features.
Well, now we can see here that the simulation is running right now. As we can see here, we have in the current state is the user is the operator. And as we can see, some features are locked or disabled, like we can see here in the code, which are velocity control, maximum height, and clear incidence, which are the variables that the operator can change due to the safety features and rules of the company. Now we can see that if we change the user for admin and we put the password 1234 and we click enter, now we can see that all of the features are available for manipulation. For example, if we click the automatic rise, it will start increasing. It will rise the curtain automatically, like here. Oh, well, first we have to set the velocity control. Since it's in zero, it's like if it doesn't work. So we need to put like an input, like a velocity. We can put like 250.
And as well, the maximum height needs to be fixed in order to proceed with the
Yeah.
values.
Now it's in zero, it would not work. We put like a 4, which is the restriction we used, or the height we chose for this project. And then we can click automatic rise, and the curtain will start rising. We can stop it with automatic brake, and we can see it stop at a desired height. We can also put it down with the automatic down button. As well, we have the manual rise and manual down, which if we keep pressing these buttons, the curtain will keep the state. For example, if I still press the rise button, it will start to rise. But if I just click once, for example, in here and down, it just does one step, like here, one step, and then I can start like doing like down in an automatic sequence. Now we have the emergency stop, which it completely stops any kind of operation that is running at the moment. For example, if I'm raising the curtain and I put the emergency stop, it will automatic disable every part of the program. I can activate anything. Also, if I click back the button, it will restart normally in the operation that was previous the emergency stop. For example, it will continue with the rise. If it reaches the maximum height, we can see the green LED that is activated for the maximum height indicator. If we put down the curtain and it reaches the bottom, we will see that the LED will start to blink in a red color to determine that is the minimum height. Now, when we are raising the curtain and it detects a person right here, no, sorry, it will be when it's going down. Imagine that the curtain is going down and then a person is passing. We click and automatically it raises the curtain for a safety feature. It raises an alarm while the person button is pressed and it registers the incident. And when we turn off the person button, which means that a person is not going in here anymore, we will see that the curtain can rise down with any problem. And that would be it for all of the simulation. And also we can see that if we are in the admin user, it can clear the incidents right here. It would set the incidents to 0, for example, in here. And the number of cycles we can see by every time the curtain rises or reaches the maximum height, it changes to 4.
Thank you so much. That will be all for our simulation of the industrial curtain of the class of elements of the mechatronics. Thank you so much.
Thank you.
Thank you.